Now we're going to develop a way of finding the surface area of a solid. So in this video, we're just going to gloss over the concepts behind it. In the next video, we're going to take it step by step. So, if you have a solid like this, this here is your function. So this is your f of x here, and then this line here, this f of x line here corresponds to this line here. Okay, so in some of the early videos, we know that when we have a function f of x, we can work out the arc length, and it was given by this. So the arc length is really a length, a one-dimensional length. And once you've got that length, if you rotate it 360 along the x-axis, then you're going to sweep through an area. Well, that area is the surface area. Okay, so the idea here is that, well, when you have a function, you can work out the arc length by using this formula here, and we've done this many times. So once you've got the wire, the length of the wire, once you've got this length of the wire, you can rotate it 360. You can rotate it 360, and that will then sweep out an area, and that area is your surface area. We're going to ignore the two ends here. Okay, we're going to ignore the two ends here for the time being. We're only interested in this area here. Okay. Well, anyway, once you've got your arc length, you can rotate it 360. That will then give you the surface area. So the idea here is that we are going to split this into many strips, into n number of strips, and later on we're going to take n to head towards infinity. So and so on here. Okay, hang on. So we're going to split up into n number of equal strips. So this bit here, hang on. So this bit here corresponds with this. So this length here is this length here. Okay, this here corresponds to this length here. Okay, so the idea here is that we're going to look at one particular strip here. Now we know this length here by using this. Okay, we know the arc length. So once you've got the arc length, we can rotate it 360. So if you look at this here, this could be your radius. If you rotate it 360, well, hang on. Let's go back one step. So looking at this one particular strip here, if you rotate this 360, you're going to sweep out an area like this. Okay, hang on, bear with me. So if you rotate it 360, you're going to get something like this, and then this band here is this thing here. Is this thing here. Okay, so if it is in a weird shape because you've got a short one here, and here is slightly longer. So this is a short side, this is a long side, because if you look at this, if you look at the radius here, this radius here, let's call it R2. This radius here is R1. Well, the radius of R1 is longer than R2. If you look at this here, R2 here is shorter than R1. So when you rotate this around here, so when you 2 pi r it, so this length here will be 2 pi the longer length, which is R1. Okay, and that so this here is your 2 pi R1, and this is your 2 pi R2, the shorter radius will give you that. Well, this here is your dx, or maybe delta x. Okay, so this here is your delta x here. So this here is your delta x. Well, the point is that once you've got your arc length here, if you get your arc length, so once you've got your arc length, let's just say the arc length is this block here. We're going to times it with 2 pi r. So we're going to times it with 2 pi r. But the thing is, the thing is, which r do you use? This r here is longer than this r here. So which radius do you use? You've got a length. Once you've got your length, you can 2 pi r. But the thing is, which r do you use? Do you use a long one, or do you use a short one? Well, let's use the average of the two. So let's use the average of the two. So somewhere in between there's an average of the two. So the radius here is really f. Well, hang on. This radius here is f of x k minus 1. Okay, so this is the radius here. The radius here is fx_k. So that's the radius here. We want to use the average of the two. So we are going to use f of c. Well, there must be a c somewhere in between the two, and then later on we're going to take n. So later on we're going to take n. Remember, we're going to sum up all the strips. We're going to sum up all the strips, and then we're going to make n. We're going to make n head towards infinity. So as n heads towards infinity, delta x will decrease. But this f of c here is always trapped in between the two. So eventually the f of c becomes f of x. Now I'm just glossing over it. It doesn't matter if you don't understand it. So the point is that once you've got your arc length here, once you've got this length here, you can times it with 2 pi r to get your area of this one band here. Okay, so once you've got your arc length, you can times it with 2 pi r. But then this r here, you want the average of the two radii here. So this r here, the radius here is f of x k minus 1, and then here you've got f of x k. But we want the one in the middle. We want the average of the two, which is f of, let's say there's a c somewhere in between the two, and then as n heads towards infinity, this thing will decrease because c is always trapped in between the two. This c here will eventually become f of x here. It will make sense. So the surface area. So this here is your arc length here. Hang on, sorry. This here is your arc length here, and then once you've got your arc length, you can times it with 2 pi r. But then this r here, the radius here, well, as n tends to infinity, then this thing here becomes f of x. I will explain it step by step in the next video. Okay.